From the moment we wake to the second we sleep, time dictates our lives. It's the silent conductor of our days, the invisible river carrying us from one moment to the next. We mark its passage with clocks and calendars, birthdays and anniversaries. But what is time, really? Is it a fundamental property of the universe or simply a human construct? This question has fascinated philosophers and scientists for centuries, leading to some of the most mind-bending concepts in human thought. In our everyday lives, time seems straightforward. It flows in one direction, from the past, through the present, and into the future. We remember yesterday, experience today, and anticipate tomorrow. This linear view of time is intuitive and aligns with our perception of cause and effect. The past is fixed, the present unfolds before us, and the future remains unwritten, or so we believe. But what if our understanding of time is incomplete? What if the future isn't unwritten at all, but already exists, woven into the fabric of the universe alongside the past and present? This mind-boggling concept is known as the time paradox, and it throws into question everything we think we know about time's arrow. It asks a question that has no easy answer. Did the future already happen? Some theories, often rooted in philosophy rather than hard science, propose a block universe model. Imagine a loaf of bread, each slice representing a moment in time. The entire loaf, past, present and future, exists simultaneously. In this view, our experience of time flowing is merely an illusion. This static timeline implies a predetermined destiny where free will is an illusion and our lives are already written. In stark contrast, quantum mechanics, the study of the very small, paints a different picture. Here, the future is not fixed, but exists as a haze of possibilities. Imagine countless timelines branching out with every passing moment, each representing a different outcome based on probability and chance. This view suggests a dynamic and uncertain future where our choices matter and influence the path we take through the quantum foam. Section 6, Echoes of Einstein, Relativity and the Nature of Time. Albert Einstein further complicated our understanding of time with his theory of relativity. He showed that time is not absolute but relative to the observer's frame of reference. Time slows down for objects moving at high speeds or experiencing strong gravitational forces. This concept, known as time dilation, implies that the future might unfold differently depending on your location and speed in the cosmos. Section 7. Can we change the past? The grandfather paradox. One of the most intriguing thought experiments related to time travel is the grandfather paradox. It asks, if you could travel back in time and prevent your grandfather from meeting your grandmother, would you cease to exist? This paradox highlights the potential contradictions inherent in altering the past and raises questions about the nature of causality and the limits of our influence on the timeline. Section 8, the unanswered question. What does it all mean? The question of whether the future has already happened is ultimately a philosophical one, at least for now. Our current scientific understanding provides glimpses into the nature of time, hinting at its complexity and the limitations of our perception. We are like children gazing at the vast ocean, fascinated by its surface while its depths remain largely unexplored. Perhaps the most important takeaway is not the answer itself, but the very act of questioning. The mystery of time reminds us of the vastness of the universe and the limits of our knowledge. It encourages us to embrace the unknown, to explore the boundaries of our understanding, and to never stop asking the big questions. For in the grand cosmic dance of existence, time remains one of the most profound and enduring mysteries of all.